In this video, I will demonstrate the working principle of a vacuum pump using a simple experiment by using a vacuum pump, a empty water bottle and a closed glass of water. Let's start this. Here the vacuum pump is connected to a manifold gauge. At the start, the system is at normal atmospheric pressure, so the gauge reads 0 relative pressure. Once I turn the vacuum pump on, it begins removing air from the systems. In this step, I have connected an empty bottle to the vacuum pump. As the pump removes air from inside the bottle, the internal pressure decreases. This clearly shows how strong atmospheric pressure is and how a vacuum creates a pressure imbalance and crosses the product. Now let's look at this closed glass of water connected to the vacuum pump. When the pressure inside the glass is reduced, the boiling point of water also decreases. That's why you can see the water beginning to vaporize without any heating. This is the same principle used in HVAC systems during evacuation, removing moisture by lowering the pressure. So from this experiments, we understand that a vacuum pump removes air and moisture from the refrigerant line of HVAC systems. This is a vacuum gauge, or also we can say micron gauge, to measure the vacuum. In the manifold gauge, the reading shows 30 inches of mercury. The reading shows in micron gauge is 1035, and you can see the reading is decreasing. Okay, so that means the micron represents very small pressure levels. 1 micron is 1000 millimeter of mercury, which allow very precisely measurement of deep vacuum. As the vacuum improves, the value keeps dropping. This shows the actual condition of the systems. When you do use micron gauge, you should ensure that the vacuum should be below than 500 micron for good result. The manifold gauge shows 30 inches of mercury. That doesn't mean the system is in a proper vacuum. That's why a micron gauge is important for doing the vacuum in AC system.